I'm going to show you one more example where we go back in our table to find where x equals 0, and then I'll show you a shortcut in case you're interested in using more algebra to solve it. But here's our review of going back to find 0. First, we find our change in y and our change in x throughout the table. So from 7 to 13, that's an increase of 6. 13 to 16 is an increase of 3. 16 to 24 is an increase of 6. 24 to 30 is an increase of 6. Now I have my x's. 1 to 3 is an increase of 2. 3 to 4 is an increase of 1. 4 to 6 is an increase of 2. And 6 to 8 is an increase of 2. So what I want to notice is when my y is changed by 6, my x is changed by 2. Or when my y is changed by 3, the x changes by 1. And that's because the ratio would be y over x, which 6 over 2 would reduce to 3 over 1, or just 3 over 1 originally. It's already reduced. So this is the slope I'm looking for. Now, in order to get to where x equals 0, I need to look at how far I need to go back on my x. And that needs to be a change of 1. So I'm going to look for another place where I changed by 1. When x changes by 1, it looks like my y changes by 3. So when I change by 1 here, I need to change by 3 here. I'm going backwards, so I'm going to decrease by 3, and I'm at 4. So I have that when x is 0, y equals 4. So that's my strategy going back to 0 on my graph. Now here is the other way. So for my more algebraic way, first I write out my equation, y equals mx plus b. And if you remember, m is the slope, and b is the y-intercept. Okay? Now we're going to pretend like we have not found this where x equals 0 yet, because we're doing our algebra way to find that. So all we have is our change in y and our change in x, and we actually know our slope because we did find that out. Our slope is down here, 3 over 1, which is 3. So I'm going to fill in the slope instead of the m. So when I rewrite my equation, it's going to be y equals 3x, that looks like a proportional relationship, plus b. And I don't know my y-intercept. That's what I'm trying to find out. So I'm going to keep this as a letter because it's an unknown. It's a variable, so it's an unknown. But I do know what x and y could be. At one point, x and y are 1 and 7. So in place of the x and y, I'm going to pick an ordered pair, which I picked 1 and 7. You could pick 3 and 13, 4 and 16, 6 and 24. I'm going to pick the x and y right here at the top to put in to my equation. So I'm going to say, okay, when y is 7, and I'm just copying this down, when y is 7, I know that x is 1. And then I leave that y-intercept there because that's what I'm solving for. And then I just solve it like a math problem. Right here I have a multiplication problem, 3 times 1, and that's 3. Then I copy the rest. So now I have 7, or y, 7 equals 3 plus b. So this is my unknown. 3 plus what would give me 7? Well, I know that 7 equals 3 plus 4, which means that b would have to equal 4. So that would mean that my y-intercept, which is the b, my y-intercept equals 4. And if you remember from the way we just did it, we got that when x is 0, y is 4.